radicals. I mean mathematical radicals. The roots is what they're also called. So for example, somebody tell me, please, what the square root of 144 is.
12.
Yeah, because what's the idea? Yeah, square root says, what does it take 2 of to make that number? How do I know it's asking me for what does it take 2 of? Not 3 or 4 or 5. What would it look like if it was asking me, what does it take 3 of to multiply me something? Because this symbol means, what does it take 2 of to multiply me 144?
An exponent there?
Yeah, not really an exponent, but like the opposite of an exponent. So if I had this, what is that asking? No. That would be this. That's what is 8 times 8 times 8. This is the opposite. This was what does it take 3 of to make 8? What do you have to multiply 3 of to make 8? 2. I like it. All right, so at the most fundamental level, radicals, which is what this symbol is called also, are also the opposite of exponents. Okay, I like it, maybe. So cube root is the opposite of a cube. Kick ass. So this is true because 2 to the third is 8. So how the shit would you start working on something like this? What do you got, Jeff? Oh, yeah, sure. And I love it. You're all like, we're human, right? What are you trying to do to us? Well, what do you think? Why was it so easy? Because what is it easy to do with 8? Tear it apart, right? You tear me apart. Same thing with this, really. This one you probably have memorized, hopefully. Right? That thing, you ain't got that sucker memorized. If you do, you're wasting your brain space, but that's all right. So you start to try to break it down. Can anybody see what goes into 729, 729? 729. What definitely goes into it? What's 7 plus 2 plus 9? 7 plus 2 plus 9. 18. That's a multiple of 9. So what goes into 729? 9. I told you about that, right? That's one thing that everybody used to know. Everybody used to know. If you add up all the digits and it's a multiple of 9, then 9 goes into it. That's just a product of how we set up our number system. But it's good to know. So how many times does 9 go into 72? 8, and then 9. And what's 81? So what does it take 3 of to make a 729? 9. Because that's what it's asking, right? It takes 3 9s. Okay. So am I saying we're going to do exactly this sometime in the stats course? No, I'm not saying that. I'm just saying we're going to use radicals, and the more you understand them completely, the easier the problems we're going to do will be. Maybe. You guys all right? And you're like, I would be if you stopped to ask me how freaking all right I am. All right, I'm sorry. Okay, so that's one thing. Here's the other main thing for today. And we're actually going to work with this today and then a little bit more next time, I think, too, just to keep this in our brains. This is going to be huge. And this symbol you guys might know if you're looking at university and you're thinking about possibly joining a fraternity or a sorority. What kind of names do fraternities and sororities have? Does anybody know? Greek letters, right? Right? I'm a Pi Alpha Delta. I'm a Sigma Sigma Sigma, right? Oh, that's terrible, Jeff. Too bad. All right. So there's one Greek letter. It's basically the Greek equivalent of capital S. And that symbol is freaking looking E. Okay, the name of this is huge. This is big. We're going to use this a lot this entire semester. It's going to show up like more than half the time. This is going to be a big part of a lot of the equations we use. And the minute I tell you what it does, you'll see why. But its name is sigma. Okay, I like it. A little aside, lowercase sigma, I like to say lowercase sigma looks like a little fat R. Looks like an R with a belly. This is not an R. You start on the belly and you go around like that. Depending on my mood, I get skinny sigmas, I got fat ass sigmas. But they're not R's. Are you with me? A little bit. R is going to mean something else later. We're going to use this symbol very soon also in 160. Kick ass. How are we all doing? And remember, I told you on the first day, I think I said this, what gets people down about statistics, part of it is all the Greek letters we use. Okay, I like it. So what the shit does this mean mathematically? What this means mathematically is, it actually would have to have something with it. It would mean the sum of whatever that is. So you see why we chose the letter S. Right, so we're like, we don't want to use S. So let's use something that makes it look more, let's use Greek. So that's the history of that. That might be the drunk history of that. Okay. The drunk history fans? Where? So let's see how this thing works with a mathematical problem. Let me make a list of data. You do it, Jeff. Wait, let me not use this. That's going to be an example in there. Let me use some different ones. 1, 2, 5, 11. Sure. Okay. So there's a data set. Talked to 4 people, and I asked them how many pets do they have. 11, yes. They have some fish and some cats and some goats and some pot-bellied pigs, whatever. And one big old snake that gets bigger and this number goes down. There we go. Let me put it like this. Same thing, right? Just in a little different format. Is that cool? It's the same thing. I'm going to mess with this in a minute. But right now, what would the value of this be? Can somebody read that to me in English? Don't say sigma x. Tell me what the meaning of it is. The sum of x. So of course, what would that be? What would the value be? Yeah, just add them all up, right? Kick ass. Is that cool? The sum of x. Well, there's x's. Let me sum them up. Kick ass. Can somebody help me? How would you do this one? The sum of x squared. Let me write this up here. This room is so weird. It's really weird. Put it up here. Sum of x squared. Now, real quick. This is different. This is different from this. Those two are different. Whatever you say, Jeff. What's order operations say? Do I add first or square first? Square. So this one I'd have to get a bunch of x squares. So what I always tell people, again, we're going to see a lot of equations this entire semester in 160 that are going to have this symbol in it. And you just have to create a table that has the right numbers to add up. Because that's all that symbol means is add up. Well, first I got to get a whole bunch of freaking x squares and then I can add them up. So can you get a bunch of freaking x squares? Maybe that's going to be this column. So what's x squared here? That's crazy. What's x squared here? Amazing. 121, yeah. Kicking the ass in. Good.
No, like, I just...
No. This happens all the time in math. Okay, one thing is the Greek letter. And you're like, Greek. I have to know Greek now? No. It's just another symbol like a square root symbol. Why is a square root basically, if I ask you a bunch of square root questions like what's the square root of 25? Is anybody going to go, ah, shit? No, I would hope not, right? You should all be like, yes, give me more of this shit. Why is that easy? Because we've internalized what that symbol is asking me. That symbol represents an entire question. What does it take 2 of to multiply by the thing that's inside of me? But math people, we don't like to write a lot. Because a lot of us write like I do, and that's horrendous. So we like to not write a bunch. So we like to take a whole sentence and then put it into a symbol. So what sentence does this represent? What's the sum of the shit in me, right? I like it. So the first thing you got to do is get a bunch of those, and then I can add them up. So what is the sum of x squared? Yeah, 151. If you add them up, good. 5, 30, 151. Is that right? What would this be? Why does order of operations change here? Because what's the very first thing? Yeah, why? Because the very first thing in order of operations is parentheses. And what's inside the parentheses? Sum. And I know what the sum of x is. No. 19. Sorry. No. The sum of x squared is 151. What's the sum of x? 19. And then I do what to it? Square it. Real quick. Now watch this. I know some of you guys are going to look at me like you always do. Sorry. I know you have calculators, but watch this. One way to do this. What's 19 times? This is 19 times 19, right? Isn't 19 20 minus 1? Right? 19 is 20 minus 1. Ooh, amazing, Jeff. But then can't I do 400 minus 20 plus 1? So this is 361. Anyone want to check me? Yeah, okay. Have you guys ever seen that? Remember learning foiling? Remember that? Maybe? You guys, whenever I teach foiling, I like to show that there is a concrete usefulness to it. Not just algebraic manipulation, but it's freaking useful in real life with real numbers. Okay, maybe. I don't know if anybody are going to use this, but I use this all the time. And then my students don't know about it, and they're like, wow, how do you do that shit in your head? And I'm like, because I know algebra. Okay, maybe. Is that all right? So there's a difference between this and this. Remember, it's related to this evil question from algebra. These two questions. They're not the same number. Yes? What would you do first here? Square. This is negative times 2 squared. So that's 4. So the answer is negative 4. What do you do first here? Squared. What's negative 2 times negative 2? Positive 4. All right, okay. Yes?
Wait, so the parentheses isn't from, oh wait, the last bit negative, never mind.
Okay, all right. Let me do one more of these. Let me take all this away. Let's take this. Let's make another set of data. Okay, I want you to take this data, and I want you to find this. Does anyone remember? 1, 2. You could do this. You need paper. And you need to write on the paper. not even, well, I mean, technically you don't really need a calculator. So you can do this a couple different ways. So remember, if you have an equation and it's got a sum symbol in it. What's up? All right. Cover that bad boy, and now you see what kind of a list you need to create. I need a list of x minus 10 squares. So I could do, let's say, x minus 10 first. So what's x minus 10 here? You didn't have to do it in 2 steps, but you could. Because then what would I do with these? I would square them, right? So now this last column is going to be a bunch of x minus 10 squares, and then I can do what this is asking me to do, add them the hell up. So what's this square? So if I add these up, I will get the sum of x minus 10 squared if I add these up. 317. Yes, no, maybe so. So summation is unbelievably basic of an idea. This summation symbol is what we call it. This big E just means sum up this. All right, well, first I have to make this so then I can sum them up. It's amazing. I like it. By the way, one thing about this, a letter we're going to use a lot in statistics makes sense is going to be n, and n is going to represent the number of data points. So what would n be for this problem here? 5. There's 5 data points. So what if my equation said this? I would just have to divide that number I got by 5. Yeah, I like it. Okay, so let me unleash you guys. This is page 40 in the book, if you got the book. If you got the book. Oh, yeah. So part of this is order operations, part of this is radicals, and then the last part is summation